The next principle is known as the Hund's rule. So the Hund's rule, it talks about suborbitals or degenerate orbitals. Degenerate orbitals. Or suborbitals. What are degenerate orbitals or suborbitals? They are orbitals of the same energy level, or in simple words, they are orbitals with the same n and l values. We call them degenerate orbitals or suborbitals. Is that okay? Orbitals with the same energy level, or orbitals with the same n and l values. So considering the orbitals arrangement here, in the magnetic quantum ideology, the S is only one, there is still S. But the P exists in 3 forms. The D exists in 5 forms. The F exists in 7 forms. Is that okay? Alright, so let's take the P. So the first P comes in the second energy level. So we have the 2P. The 2P exists in the 2Px form, the 2Py, and then the 2Pz form. Is that okay? So all these are in the second energy level, and they belong to the P orbitals. So orbitals of the same energy level, we call them degenerate orbitals, or they are suborbitals of the P orbital itself. Is that okay? The Px, the Py, and the Pz. To also explain it, we also use orbitals with the same n and l values. What is the n value here? The n is the principal quantum number here, and our l here is the P, and the l here is what? 1. Our L here is 1. Don't forget, we said the azimuthal quantum number can have values 0, 1, 2, 3. 0 represents S, 1 represents P, 2 represents D, in that order. In our previous lesson, is that okay? So the N value here is 2, and our L value here is 1. Our M value here is 2, and our L value here is 1. Our N value here is still 2, and our L here is still 1. So orbitals with the same n and l values, we call them degenerate orbitals or suborbitals. And Hund's rule is particularly about degenerate orbitals. He said when we have orbitals of the same energy level, or when we are considering the suborbitals, before we fill them, we should fill them singly first. We should fill them singly first, and once you fill them singly, you should indicate a parallel spin to indicate that single electron. Before, if there are more electrons, you double pair them with opposite spin as well. When you're considering degenerate orbitals, we singly fill them first with a parallel spin before we double fill them with opposite spin. Is that okay? So back to the first example that I just used recently, that is carbon. So carbon atomic number 6 has a configuration 1s2, 2s2, and then 2p2. Is that okay? And I said that a p orbital exists in 3 forms. That is the 2px, the 2py, and then the 2pz. So these are 2s, and then this is our 1s orbital for carbon. Is that okay? So according to Hund's rule, so we can fill the 1s, 2 electrons, 4 electrons left, 2 electrons to the second s. Now we are left with 2 electrons, and we've entered orbitals with the same energy levels, the degenerate orbital. So we don't just give the electron to the px, as I indicated when I was illustrating the Pauli's exclusion principle. Is that okay? Once I give the remaining 2 electrons to the 2px, I'm violating Hund's rule. Why? Because Hund's rule says that when you are filling degenerate orbitals, we fill them singly first. So it means that these 2 electrons, I have to give the px 1 electron, and then the next, the py also 1 electron. If there is another electron left, that is when I can double pair them. Is that okay? And I don't put all the 2 electrons on the 2px. Once I put all the 2 electrons on the 2px, I'm violating Hund's rule of maximum multiplicity. Is that okay? So according to Hund's rule, we need to give the 2px 1 electron, and then the 2py also 1 electron. But Hund's rule also talks about the spin. Once I indicate one electron or singly, I indicate one electron on it, I also have to indicate the spin as well. Is that okay? So the moment you are given a configuration, let's say of this nature, but we have an opposite spin here and then 2 electrons here. Then they'll ask you to study the configuration above. Which principle or rule is violated here? So once we have degenerate orbitals here, you could see that all the 2 electrons remaining are given to the 2px. So quickly, you say that the Hund's rule is being violated here. Because according to the Hund's rule, you need to give the 2px 1 electron and then the 2py another electron. But since all the electrons are located on the 2px orbital, it means we are violating the Hund's rule of maximum multiplicity. Is that okay? Let's consider another element. Let's take nitrogen. Nitrogen is atomic number 7. So it has a configuration 1s2 according to Alpha principle, 2s2, 2p3. Is that okay? Now, let's move on to the Hund's rule with this one as well. So we are now filling the 4 electrons for the first 2. Now when we get to the degenerate orbitals, since we have 3 electrons left, we need to give each of them 1 singly first. That is according to Hund's rule. And we indicate their spins as well. Once we do this, Hund's rule is satisfied. But when I give the 2px 2 electron and I give the 2py 1 electron and the 2pz has no electron, and I indicate the spin here, once we are considering the degenerate orbital, I can identify the Hund's rule violated here because I needed to give them 1 electron first before I double pair them. Is that okay? Let's consider one last example. That is, let's look at oxygen. So oxygen atomic number 8 has a configuration of 2p4. So this is oxygen. Is that okay? So we are now filling the 1s and then the 2s, but it has 4 electrons in a p orbital. How do we distribute these electrons among the suborbitals? So that's where Hund's rule comes in. According to Hund's, we need to give each of them 1 electron first and then indicate their spins in a parallel form. Is that okay? Now, since we have 4 electrons, we diffuse 3 electrons, then we begin to double pair them. So we are going to pair this one with the last electron. Is that okay? And then we indicate its opposite spin. Once I do this, Hund's rule is satisfied. But the moment I put 2 electrons here and 2 electrons here, and I indicate the spins here, I'm violating the Hund's rule of maximum multiplicity. Is that okay? So that is the principle that guides how to arrange electrons in an orbital. Is that okay? So that is the principle. So the first one is the Albers principle, also known as the building up principle. Alba is a German word which means building up. It means anytime we want to arrange electrons in orbitals of an atom, we start with orbitals with the lowest energy level. Gradually then move on to those with a higher energy level. Is that okay? As we did here. And the second principle is the Pauli's exclusive principle. It says that the maximum number of electrons an orbital or each orbital should accommodate is 2, and it should have an opposite spin. And the last one is the Hund's rule, which talks about degenerate orbitals. Once you are filling degenerate orbitals, orbitals with the same energy level, or orbitals with the same n and l values, we singly fill them first with a parallel spin before double filling them with their opposite spin. Is that okay? So that is electronic configuration using a quantum ideology. If you have any question or any contribution or if there is any confusion, let me know in the comment section. Thanks for being with me today. Don't forget to subscribe to the channel. We'll meet again in our next lesson. Goodbye.